Let's graph x squared minus 16 over x squared plus 4x plus 4. I'm going to find my x and y intercepts and give me some puzzle pieces here. I'm going to make f of x y. So y equals x squared minus 16 over x squared plus 4x plus 4. It's okay at this time that you factor or you don't factor. It does not matter. 0 is y, so substitute it. If you cross multiply, you're just going to get x squared minus 16 equals 0. Here you could factor to solve, or you can just use the square root method. That's right? So I have x squared equals 16. If I take the square root of both sides, x is equal to plus or minus 4. My order pairs are 4, 0 and negative 4, 0. Is that alright?
Yeah, I always forget this.
Alright, let's find the y-intercept. X is equal to 0. So I'm going to write the original problem. I'm going to make every x value 0. So 0 squared is 0 minus 16. 0 squared plus 4 times 0. 0 plus 4. Y is equal to. So 0, negative 4. Raise your hand if you got that. Okay, what's next? Yes, Delia. Not Delia. Mariana, sorry. That's on video. They're twins. It's hard. I've had them for like 2 years. Vertical asymptote. Mariana, how do you find that?
Don't you factor each one?
Okay, good. Factor each one.
I got, for the one on top, I got x plus 1, x minus 1.
Good. Okay.
At the bottom, I got x plus 2, x plus 2.
Okay, this is where you were thinking, I made up this problem and I wanted them to cancel, but they don't. So, they don't always cancel. Okay, so how do I find a vertical asymptote?
It says cancel for the second step.
Which is what?
Set the denominator not equal to 0.
Set the denominator, either of these, I would pick this one, not equal to 0. What's next?
Solve it.
Solve it? How do I do that?
Do we combine?
You're going to set each one of those
Oh, not equal to 0?
not equal to 0. It's kind of weird to do the same problem twice. Yes?
Yeah.
So really you just have x is not equal to what?
Negative 2.
Negative 2. Raise your hand if you got that. Good, good, good. Tell me about horizontal asymptotes. Alexa. Uh-huh. What would I circle on both of those? Notice how on the factored side, a student asked me this. Can I pick, I guess it does become the same, but don't think the highest power is a 1. Remember, it's x times x, which gives you x squared. So we're going to compare the 2's, the exponents. If they're equal, what do? Reduce. What does that mean? X squared divided by x squared is equal to 1. So be careful when you're canceling here, that equals 1. So y equals 1. Raise your hand if you got that. Good. Let's graph it. So vertical asymptote at -2. Dotted line, straight edge. Mariana.
Sorry.
Put a check mark by it if you want. No, you did it. I have a horizontal asymptote at 1. So I'm color coding my graphs here so you can see it. Raise your hand if you got that so far. Okay, normally rational functions have 2 curves in the opposite. Usually. Let's graph our x-intercepts. 4, 0, -4, 0, and 0, -4. Looks okay so far? Okay. What values to pick for our tables? Now here, this pink line is at -2. And basically what we want is a couple of values to the left. So Brooklyn, what values did you pick?
5.
What did you get?
I got 1.
Keep going.
-3. I got -7.
Okay.
And -1, I got -15.
Okay.
-15.
-15? Thank you. Keep going.
Can I get on the positive side?
Sure.
Okay. So for 0, I got -4. 1, I got -1.627.
Negative what?
1.67.
-1.67.
-1.
Point.
Sorry.
No, I have hearing issues.
And then 2, I got -0.75.
Okay. Let's graph them. -5, 1. 1, 2, 3, 4, 5. 1. Uh-oh. Did you guys see this?
Yeah.
On my asymptote. Oh, no. -3. 1, 2, 3. -7. 4, 5, 6, 7. -1. -15. Totally fine. 2, 4, 6, 8, 10, 12, 14, 15. Really far down there. 0, -4, which we have. 1, -1.67. So between -1 and 2, and then 2, -0.75. Okay? What happened if you guys put in -2, 4, 6? -6. Mariana, what'd you get?
1.25.
Hmm. 1.25. 2, 4, 6. Okay, so this is what I think it'll look like, but I'm a little bit hesitant because of that horizontal asymptote, right?
Mm-hmm.
If you miss like I did right here, just make your lines bolder. It's like an art class. And then this one looks like it comes up. Do you guys see it?
Mm-hmm.
Alright, let's double check this one here. X squared minus 16 divided by x squared plus 4x plus 4. And then I want my graph. Right? It looks like it's evening out there. What values do you guys see that approaching?
It decreases.
Yeah, it's decreasing, but what number do you think it's going to go towards? As I keep going left, what's happening to the number?
The y value or x value?
The y value.
It's decreasing.
But it's getting closer to what number do you think?
To 1.
To closer to 1. So our graph, I think, I gotta think about this one. Let's change our window, see what happens. Negative 50, count by 10. That's what happens. So our graph, it looks like that it actually goes down, doesn't it? Not up. So it's never going to touch the asymptote. I think, well, if I put in those values, negative 6, we're saying that it should never touch 1. What would happen if you put in 1? Negative 15, 1, 4, 9, negative 15 over 9, you get a value. Now what number do we not want? Negative 6. We got a basic sketch, which is good, right? Alright, so we talked about how that one does go over this horizontal asymptote. That is actually possible. What happens is that it's, we went on our calculator and showed you that it's just eventually keep going, approaching 1. So horizontal asymptotes, it's okay, you can go above or below your asymptote. It's the vertical that will remain undefined. Thank you, Mr. Alcar, for that correction.